Hi, what's up guys? Welcome to this lecture, Angles of a Transversal, Important Results to Remember. In this, I'm going to cover all the important results so we can do various number of problems from various Olympiads. So this would be really helpful for PRMO, AMC, and it will be an introductory lesson for AIME and RMO. So we even get many questions from AIME and RMO. But it's not so common. So with these important results, we could solve many questions in PRMO and AMC, and we could solve the first part or the first half or some part of the question from RMO and AIME. So in this course for geometry, we are gonna use a book called A Beautiful Journey Through Olympiad Geometry, and the book is by Stephen Lazinowski, weird name though. So you will find this PDF in my Telegram channel. This is a really good book. It's gonna cover from AMC to USAMO and from PRMO level to more than INMO, much more than INMO geometry. It's a really good book. Even I study from this book myself. I study like every day from this book for geometry. So let's start. So what is the property 2.1? So if we have two parallel lines just like this, and we have a transversal, and we say that this angle equals to this angle equals to this angle, and this angle equals to this angle. So there are some names called vertically opposite triangles, corresponding angles, and there are some other names, so I don't remember those. So I just remember the vertically opposite angle. So if there are two lines, so this line has to be equal to, this angle has to be equal to this angle, and if these two lines are parallel, this angle has to be equal to this angle, so it's always vertical. And similarly, if I use another pen to denote, this angle equals to this angle equals to this angle equals to this angle. It's a really simple concept. So now let's go to property 2.1. So the property 2.1 is the sum of angles in a triangle. Sum of angles in a triangle. So what is the sum of all the triangles in the sum of all angles in a triangle? It is obviously 180 degrees. Yeah, it's 180 degrees, but most of us have no idea to prove it. So let me prove it. So if we take a triangle, we have a triangle, and then we have a straight line, which is parallel to, let me name this A, B, C. This line L is parallel to BC. My handwriting is not so good, guys, but please try to understand. So we can say that we can just extend this one to BC, and we say that these two are parallel lines, and this is the transversal. We say this angle equals to this angle, and we say that this angle equals to this angle, and this is the other common angle. So by this we have proved the sum of all the angles in a triangle is 180 degrees. Now we are going to prove the exterior angle in a triangle. Exterior angle in a triangle. Exterior angle in a triangle. So if we have a triangle and I extend the line here, A, B, C, we call this angle exterior angle, and if this is alpha and this is beta, we say this as alpha plus beta, because this one will be 180 minus alpha minus beta. And if we call this y, we say y plus 180 minus alpha minus beta is 180. So we get y equals to alpha plus beta. Next property, So property 2.4 is find the sum of all integer angles in n-gon. So n-gon is just like the triangle, then it's a polygon. So example, we take a pentagon. So we can divide this pentagon into three triangles, 1, 2, 3. So similarly, if you have a square, we can divide it into 2. So if it has 5 vertices, we were able to divide into 3. If you have 4, we were able to divide into 2. So if you have n, we would be able to divide into n minus 2. And we have 2 triangles here. So if you add the angles, these two, if you add all the angles, we get obviously we have 2 triangles, so it's 2 into 180, and here it is 3 into 180. So generally, because when you have n sides, we have n minus 2 into 180, the angle. So the next property is the exterior angle property. I mean, to find the exterior angle. Exterior angle is always 360, and let me prove so. So if we just have just a second, draw proper one. Let me draw it here. So this is, I don't know what, I think it's a decagon. So if we just extend it, so what we get is, how do I say that? So I'm assuming it is a regular one, and this is a regular decagon, and this would be true because the sum of all the integer angles is n minus 2 into 180, and we know that if the exterior angle will be 180 minus this. It will be 180 minus. So what is each angle in this? So in each angle we have, so the total angle is 180. I mean n minus 2 into 180. But if we have, because we have n sides, we need to divide it by n, because to find each angle, I'm trying to find each angle, and if we subtract 180, if this is x, so I need to subtract x to find this exterior angle. So now the aim is, I need to find 180 minus n minus 2 into 180 by n. So we got one exterior angle by this formula. It is just one exterior angle. So we need to multiply with the number n to find the number of exterior angles. So n whole into n. So let me, I'm gonna explain you guys again the whole thing. So even though you have understood this thing, but you listen to it again, because this is really logical proof what I made on my own. In the other proof, what you see from the other books, they use some summation and others to confuse you. So now, first let us find the angle. The total integer angle. The integer angle must be n minus 2 into 180, as I proved in the last one. Now I'm trying to find each angle. Because I have n sides, I need to divide by n to find angle at one side. Now I get this as x. Now to find the exterior angle, I just extend one side and I subtract 180 with x. Right. So now I have subtract. So I got this as x. So now 180 minus x equals to 180 minus n minus 2 into 180 by n. So, and now what we do is, what do we do? Because we have found one exterior angle, because we need to find the total exterior angle, we need to multiply it with n, because at n sides totally. In this case, there are 10 sides because I took a decagon. So now we need to multiply by n, which is n into 180 minus n minus 2 into 180 by n. So we get 180n minus n minus 2 into 180. We get 180 minus 180 n plus 360. So we always get a 360. Next property. So if you don't understand any property, just go back and do it. So I'm going to tell some properties. It's a really simple properties you need to prove on your own, or else I'll probably do it. No, I'll do it. So if we have an isosceles triangle, let me draw a better one. This is an isosceles triangle, and I have drawn an angle bisector, and now I know this side is equal to this side because it's an isosceles triangle, and this angle equals to this angle, as always isosceles triangle, and this is the common side. By SAS congruency, we say triangle ABD is congruent to triangle AED, congruent to AED. So we say that both these two triangles are congruent. So I have told congruency in the previous video. You can watch it. Go to my channel and watch congruency. And now because the sum of these two angles is 180 and both are equal, so we say this angle is 90 and this angle is 90, so this is perpendicular. So that's all I had to prove, that this line would be perpendicular when this is an angle bisector for an isosceles triangle. So let's look at property 2.7, which is about equilateral triangle. So in equilateral triangle, all three sides, and one more thing, because these two are congruent, so we say that this angle equals to this angle too, because both are congruent. So in an isosceles triangle, we have proved the angles opposite to equal sides are equal. And same, this is an homework, guys. You need to prove the same thing for equilateral triangle. Homework. I'll do it then. A, B, C. By drawing an angle bisector, we say this side equals to this side, and this is the common side, and this angle equals to this angle. And we also say that this is perpendicular and this angle equals to this angle. We have proved angle B equals to angle C. Now what I'll do is, now I'm going to draw another triangle, means the same triangle. Now what I'll do is, I'll draw the angle bisector here, and these two angles are equal. This is perpendicular, this is common, this side equals this side, and again we get this angle equals to this angle. We get angle A equals to angle C, and here we got angle B equals to angle C. So we have angle A equals to angle B equals to angle C in an equilateral triangle. And now let's look at property 2.8. So angle graded to side angle graded to the greatest side will be, one sec, let me draw it. Yep, this should be fine. And now the greatest side, if this is the greatest side, then this has to be the greatest angle, and I'm gonna prove that one. So now let us assume, if they're saying that this, let's assume this angle is the greatest and this is not the greatest side. So I'm constructing an angle, like this. this side equals to this side, like something like this. And now, because this is an isosceles triangle, we say that this angle equals to this angle. And because this angle equals to this angle, which is the sum of, this is the exterior angle, which is the sum of this angle and this angle. Let me show you by laser point. Man, just a second, guys. Yes, because we say too thick. Yes, because this is the exterior angle, so we say that the exterior angle is the sum of the other two interior angles, which is this angle and this angle. So then what we say is, because it is the sum of this angle and this angle, so this angle should always be less than this angle. That is the main idea, guys. So we got that this angle is greater than this angle, and we also know that to find this angle we need to add this angle and this angle, and this angle is greater than this angle. So we say that this side is greater than, because this side is greater than this side, and we also prove that this is the greatest angle. That's all, guys. So let's go to property 2.9. Property 2.9 is nothing but triangular inequality. Triangular inequality, which is if you have a triangle, oh man, this is A, this is B, this is C. We say that AB plus BC is greater than AC. So it's an easy proof. I'm gonna prove here. There is no property 2.10. So I wrote it by mistake. So let us look at that property. The triangular inequality. Now I'm gonna construct now 1 second, let me name it ABC. Now I'm gonna construct another line like this. This is equal to this one, and now I'm gonna join this one and say this angle and this angle are equal because it's the isosceles triangle, and this angle, let me write x plus y. And now we also could say another thing about this, that BD is, let me name this D. BD is always greater than AB. BD is greater than AB. Why is that so? Yeah. So in triangle ABC, I'm reading out the statement what the triangular inequality means. Let D be a point on the extension of side BC beyond C such that CD equals to CA. Then triangle CAD is isosceles. Yes, it is isosceles. So angle CAD equals to angle CDA. Now we have the triangle BAD. So in triangle BAD, what we have is, we are looking at triangle BAD. Angle BAD equals to angle BAC plus angle CAD, which is greater than angle CAD. It is greater than angle CAD, and CAD equals to nothing but CDA, and CDA is congruent to BDC. which is nothing but BDC. BDC. So by property 2.8, I guess. So is it 8? No. By property 2.8, yeah. By property 2.8, we know that greatest angle has the greatest side opposite to it. So we say that BD is greater than AB. Yes, BD is greater than AB because this angle is greater than this angle. So obviously BD is greater than BD is greater than AB. BD is greater than AB. So we get BC plus CD is greater than AB, and BC plus CD is nothing but AC is greater than AB. Similarly, we can prove the rest, which is AB plus AC greater than BC. That's all guys for this video. Thank you for watching, and please hit the subscribe button if you want more videos like this. And I'm gonna get my personal friend who's in IIT Bombay and Delhi, who would also be teaching for you guys, and once I hit 1000 subscribers. Thank you guys for watching.